The next question is June 06 paper 2. This is question 3 part C. The diagram below shows a ray of light passing through water towards air above. The critical angle for water is 49 degrees. On the diagram above, continue the ray of light showing how it behaves at the surface of the water. Now you can see that this angle of incidence is only 40 degrees. And we are told here the critical angle for water is 49, and that's the angle at which the angle of refraction is 90. So this isn't going to be totally internally reflected, and it's not going to pass along the edge here. It is going to pass out into the air, but at quite a large angle. So I'm just going to continue the normal out into the air here, and then it's bent away from the normal as it goes out again, but it's bent well away from the normal because it's approaching that angle of refraction of 90 degrees. So it's going to be something like that. So to get your marks there, you would need to make sure that you have got your normal drawn in, that you have a refracted ray bent in the correct direction with an arrow, and making sure that your angle is much bigger, and just mark it. So that gives you the correct direction. The diagram below shows a second ray of light approaching the water surface at a different angle. Remember, the critical angle of water is 49 degrees. Continue this ray to show it how it behaves at the surface of the water. Now, it doesn't tell you that it goes out into the air, and you can see the angle is 60 degrees, so 49 degrees is the critical angle. So therefore that means that it is past, or it is beyond the critical angle. So that means it's totally internally reflected, TIR. So you have to make sure, either use a protractor, and you should use a protractor. Again, I'm not using one here because I haven't got one. And try and make sure that your angle is about 60 degrees. So I'm just going to move this and hope that it kind of looks the same. Now, they won't be so fussy that the examiner will have to take out a protractor and measure every angle, but it is a good idea to make it look like it is. Mine looks a little bit big there. If you even marked it 60 degrees, the examiner would know that you meant it to be 60 degrees. And you would get one mark for the correct angle and one mark for a ray with an arrow on it, and it's reflected in the water. So this surface now is just acting like, even though the light should pass through it, it's acting like a mirror and reflecting light instead. Describe one use of optical fibres in medicine, making clear the special properties of the fibre that make it suitable for the use described. And it asks you, down the bottom it says quality of written communication 1, so that means you have to write in full sentences. So we have to talk about optical fibres in medicine. Right, so obviously the most obvious optical fibre example in medicine is use in the endoscope or keyhole surgery, but in general it's a special type of endoscope that's used in keyhole surgery. So it's used in the endoscope, and so how would you describe it? So light passes down a set of optical fibres into the part of the body being examined. And I'm going to just say a wee bit more about how it passes down. The light is totally internally reflected. As it hits the surface of the fibres. Okay, so what happens then? The light then is reflected from the inside of the body, and we could go on to say something about the body part being examined, but from the inside of the body will do. Back up a second set of fibres. So the surgeon can see the area in question. And why does this work so well? Well, so it says making clear the special properties of the fibre, so there's going to be a mark for that. So the special properties of the fibre is flexible, and that's a really big thing, because the problem with light is that light travels in straight lines and it can't bend around corners. But if you allow your fibre to be a flexible material, and the light can bend, and it bends because it's hitting the surfaces and being totally internally reflected, it means you can get light to areas which are previously inaccessible. So the fibre is very flexible. Okay, and can bend round corners. So in the mark scheme, you would get a mark for saying that the fibre was flexible. You would get a mark for saying light passes down the optical fibres, that the light's been totally internally reflected, and then it's been reflected up from the inside of the body into the surgeon's eyes. And provided you've got several sentences which are fairly correct, you should get your quality of written communication mark.